infinite series. So an infinite series is an expression of this form. So this is our summation notation. We're taking n from 1 to infinity. It's an infinite series. We're going to keep doing this over and over and over again. So we take our an, and that equals a1 plus a2 plus a3 all the way out. All right. You want to break it up to any one of the values, say you want to go 50 or 100 or 200 or whatever, then for any positive integer, you have to pick one. Then k will be the integer. Then s of k equals the sum that looks exactly the same as above, only it terminates at ak, the kth one. So if k is 50, then you would have a1 plus a2 all the way to a50. All right. Now, there's two different ways that this can go down. Either they just keep adding and adding and adding, going up and up and up and up, in which case we would be a divergent series. Or if the added pieces that we're giving it are getting smaller or converging to something. So if this is a convergence of a series, then it's going to converge to some value, and S is what we're giving out there. So if it converges, it'll converge to S. If it does not, it'll just be divergent. A couple rules. The algebraic properties would be what you would expect, I would hope. So if you take a series, the infinite series for an and the infinite series for bn, and they're both convergent. All right, so both convergent. Then by the sum rule, that converges, because that equals the sum of a convergent series, well, two convergent series. So if we take the sum of an plus bn, that equals the sum of the an's plus the sum of the bn's. Each of those converge, so the entirety will converge. Same thing if we're taking a negative. We can break that up into two different ones, which we subtract. And since they're each convergent to some number, a number minus a number will also give us a number that's not crazy infinity. And if you put any real constant c, we can pull the c out in the same manner that we did before with the other, say the limits and so forth.